test. Today we're going to be talking about research methods in psychology. Before we get started, I wanted to ask you a couple of questions to help demonstrate the importance of why we do research in psychology. For each of the following questions, there are going to be 10. I want you to write down either true or false for your answer, and then we'll talk about the right answers for each one. Number 1. The more confident you are about your memory's accuracy, the better your memory. 2. Women who are very serious about their careers are less likely to be interested in marriage. 3. Opposites attract. 4. Stress is always bad for you. 5. The more motivated you are, the better you will perform. 6. Those who threaten suicide rarely attempt suicide. 7. Punishment is the most effective way to reinforce the learning of new habits. 8. If you use imagery to remember something, the more bizarre your image, the better you will remember it. 9. Physically attractive people have higher self-esteem than less attractive people. 10. If a couple adopts a child, they will be more likely to become pregnant. Now I'd like for you to look over the responses that you just gave to each of those statements. There is a very interesting relationship between each of those 10 statements. They are all false. If you wrote true for some of them, please rewind the lecture and go back and listen again to the statement. Research in psychology has shown that all 10 of those statements are false, even though sometimes common knowledge or anecdotal evidence would say, oh no, this statement is actually true. This is why research in psychology is so important. We need to dispel myths about perceptions and behavior and show scientifically what is true about behavior and mental processes. So, if you haven't already, go ahead and open up the PowerPoint entitled Understanding Behavior Research Methods. I'm going to talk a little bit about the different steps that we take when we perform research in psychology. Starting with the first slide, I want you to know that there are 2 goals in psychology research. The first is to understand behavior and mental processes. That is, to capture what it is that people do, and when we can, try to understand the underlying brain mechanisms that mediate that behavior. When we have captured behavior, then we can apply it, whether it be a business setting, an organizational setting, an interpersonal setting, or a therapeutic setting. So once we understand behavior, then we can use that information to help in a variety of settings. One of the most important things to remember when we conduct research in psychology is that our findings shouldn't apply to just a small sample of people, or even necessarily just one person. Ideally, most of our findings in research should apply to entire populations. Findings should be consistent from group to group in different settings, otherwise the results that we obtain aren't necessarily as helpful. For this lecture, I'm going to focus on one phenomenon to frame the different steps in research in psychology. I'm going to use the phenomenon of addiction to frame this lecture. So most of the examples will be with respect to addiction. Not all, but some of them. On the next slide, what you're going to see is the first step in research in psychology, and that is to state your hypothesis. A hypothesis is a testable statement of relationships between variables. Again, a hypothesis is a testable statement of a relationship between variables. So we have a couple of important characteristics here. The first is that it is written as a statement or a sentence. Hypotheses are not presented in the form of questions. Secondly, the relationship has to be stated in such a way that we can actually test it through research. So I'm going to give you two examples of what I would consider to be good hypotheses. First one, people who complete a drug rehabilitation program are more likely to abstain from drug use. As you can see, this was in a statement form, and it expressed a relationship between two variables, participating in a drug rehabilitation program and abstinence from drug use. Hypothesis number 2. There is a relationship between the amount of time spent in a drug rehabilitation program and the number of days sober after completion. This is another example of a good hypothesis. It's a little bit different from the first one, but the two major components are there. It is a statement, and it is something that we can test. If you go to the next slide, I want to talk a little bit about how we design a study. One of the hallmarks of good research is to obtain a good sample. In an ideal world, we would obtain what's called a random sample. That is, if we use a population of people with addiction, we would be able to randomly select people to conduct research on from that population. Random sampling is not always possible because it requires us to obtain a list of all possible participants that we can then choose our sample from. So when it's not possible to obtain a list of all possible participants, then we can move towards something called representative sampling. This is where we try to get a sample that is as representative as possible of the population. We might seek to obtain a sample that is representative for gender among people with addiction, among the different age groups in the population with people of addiction, ethnicities, religious background, whatever your variable of interest is. So again, in a perfect world, we would obtain a random sample. When that's not perfect, our next best thing is to obtain a representative sample. Before we can go further in testing our hypothesis, we have to be clear on what the variables are that we are going to test. This is crucial in psychology because not all variables that we study are automatically defined for us. It is up to the researcher to define the variables that he or she is measuring. Not all researchers will define variables in the same way, and sometimes that leads to disagreement within the research. When we define a variable for research, we use what's called an operational definition. An operational definition is defining a variable by how we are going to measure it. Again, an operational definition is defining a variable by how we are going to measure it. Let me give you a general example. If I was interested in studying the variable of depression, we all know what depression looks like. Some of us may have experience with what depression feels like. But in order to conduct research on depression, a researcher would have to have an ironclad definition of what it is he or she is studying. Operational definitions are usually defined within one of three categories. One category is self-report. A person can report that he or she is depressed by taking a survey, and that survey yielding a high depression score, or simply by saying, "I feel depressed," or "I think I am depressed." that criterion might be enough for someone to be considered to have symptoms of depression. So that's an example of self-report. A little bit more objectively are behavioral measures that can also be used as operational definitions. Clinical psychologists have defined certain behavioral measures that are analogous or symptomatic of depression, such as problems with sleeping, either sleeping too much or too little, problems with eating, eating too much or too little, or problems interacting with others. These are all behaviors that a researcher can observe and make the conclusion that someone might be experiencing depression. So again, another way to operationally define depression is to use behavioral measures. A third way to operationally define a variable is to use a physiological measure. People with depression tend to have lower global metabolic activity in the brain. This can be shown on a PET scan. So this is another way that we can demonstrate that someone has depression. None of these measures in and of themselves are necessarily conclusive, but when you put self-report, behavioral, and physiological measures together, it makes it more likely that you have a strong case for the variable that you're measuring. In addiction research, we also have operational definitions of variables. One example is that of sobriety. Sobriety can be operationally defined in many different ways. Conceptually, sobriety is defined as refraining from drug use, but the definition of how long someone has refrained from drug use can vary. Some drug treatment programs define sobriety as 30 days sober. Other programs may be 60 days sober. Another program may be 90 days sober. Some drug treatment programs define sobriety as simply staying sober until the end of the program. So you can see there can be a lot of disparity as to how a variable is defined. That is why it's so important for researchers to clearly communicate how they're defining a variable, because there's a lot of variability from one research study to the next. The next step in research, if you go to the next slide, is to collect the data. After we have chosen our sample, after we've stated our hypothesis, after we have clearly defined our variables, we then have to collect the data. There are two major approaches to collecting the data. Generally, they are categorized as non-experimental and experimental. Non-experimental research is research in which we try to understand relationships between variables, but we're not necessarily trying to determine a cause and effect relationship between variables. Again, non-experimental research is when we conduct research to determine relationships between variables, but not necessarily a cause and effect relationship between variables. On the slide, you see 3 examples of non-experimental methods to collect data. The first one is called naturalistic observation, or simply observation. In this type of data collection approach, we simply observe behavior as it occurs and record it. The researcher is not doing any kind of intervention, any kind of experimental manipulation, or any kind of treatment. So the researcher simply observes the behavior that is occurring and records it. The advantage to this is that observation is completely non-invasive. You can stand some distance away from a participant and record behavior even without that person's knowledge that his or her behavior is being recorded. So one of the advantages is a person may or may not alter their behavior. they may actually demonstrate their natural tendencies. A disadvantage of naturalistic observation is that, again, because we're not doing any kind of intervention or treatment, there's no way to establish cause and effect relationships between variables. If we were simply observing someone in a drug-taking environment, we really would not have a way to understand the causes of that drug-taking activity. All we're doing is simply observing what the person is doing, not why. The second non-experimental approach to data collection is a case study. A case study is a very detailed study of just one or at most a few subjects. Most of the time, these people have been exposed to an extraordinary circumstance or event that makes them special. There is one example of a group of teenagers in California who many years ago, over 30 years ago, tried to synthesize heroin. They tried to artificially manufacture heroin. When they took the substance, the experience was similar to taking heroin, but unfortunately, the drug that they had synthesized had devastating effects on their motor systems in the brain, and this small group of people ended up with symptoms of Parkinson's disease, and they were only in their 20s. Parkinson's disease usually doesn't have its onset until the 40s or later. So this would be an example of a case study. This is a very unique group of individuals in a very unique circumstance, although unfortunately, this was a sad circumstance. The advantages to a case study is that we can get a very detailed report of behaviors because there is a lot of direct observation and direct study in this focused group of individuals. The drawback to a case study is that it is hard to generalize the results to everyone. Would everyone who takes this drug develop Parkinson's symptoms? It's hard to say if the results would generalize to a larger population. So that's one of the drawbacks of a case study. Usually the results are restricted simply to that small group. The third non-experimental approach that I want you to know is a survey. In psychology, we have surveys for almost every psychological phenomenon you can think of. We have surveys to measure things like substance abuse and addiction, depression, anxiety, obsessive-compulsive tendencies, procrastination, even something like the quality of your dating experiences. If you can think of a variable, it is likely that there has been a survey created for it. One of the advantages of using survey research to study a variable is that it allows us to gather a lot of information quickly about our sample. The drawback, obviously, is that not everyone is necessarily truthful on their survey responses. It is less likely that we will get honest information from them, as opposed to simply observing them or doing a detailed case study. So as you can see, each of these non-experimental approaches to research have benefits and drawbacks. But again, all three of these share the common bond that we cannot assess a cause and effect relationship between the variables that we're studying. We can simply understand what the relationship is between the variables. If you go to the next slide, you will see the next approach to data collection, and this is called the experimental approach. The experimental approach is when we try to understand the cause and effect relationship between variables. An experimental design is the only way in which we can do this. Using this design requires that we are very particular in defining our variables. We have two. The first one is called the independent variable, or IV. This is the causing variable. In order to determine if a variable causes some change or causes some effect, we have to be able to compare two conditions. So on the slide, you will see that the independent variable must have at least two levels. I'll talk a little bit about that in just a moment. The independent variable can be assigned, as in the researcher places you in one condition or another, or the independent variable can be naturally occurring. For instance, one group of participants has had a certain experience, one group of participants has not. The naturally occurring variable can also be something personal. It can be a characteristic of you. For instance, it can be something like how far you've gotten in schooling, whether or not you're a college graduate, your gender, your religious affiliation, your occupation. We would call these naturally occurring independent variables. It is not something that a researcher can assign to you. In an experiment, the second variable is called the dependent variable, abbreviated DV. This is the effect or outcome variable. This is where we see or determine the effect that the independent variable had. Often the dependent variable is numerical. It's a numerical or quantitative measure, but not always. The benefit of using an experiment is that we can better understand a cause and effect relationship between variables. The drawback is, in order to capture that relationship, often we have to set up our study in a contrived, well-controlled setting, so it's not as clear whether or not this relationship would hold outside of this more controlled setting. I'd like to give you some examples of research studies, and I want you to take a moment to identify three parts: the independent variable, the levels or groups of the independent variable, and the dependent variable. I'm going to go through one with the answers. Then I'm going to read the next three scenarios, and I'd like for you to pause between each one to determine if you can find the independent variable, the levels of the independent variable, and the dependent variable for each one. Here is an example. Children watched a cartoon either alone or with other children, and then rated how funny they thought the cartoon was. Let me read it again. Children watched a cartoon either alone or with other children, and then rated how funny they thought the cartoon was. In this study, the independent variable is the cartoon watching condition. That is the cause, the cartoon watching condition. There are two levels, alone or with other children. Two possible groups, two possible situations. The dependent variable is the funny rating. In other words, it is hypothesized that children who watch a cartoon alone may rate a cartoon funnier or maybe less funnier than children who watch a cartoon with other children. The way I've stated the independent variable, the levels of the independent variable, and the dependent variable can be a little bit different. There isn't one set answer. Another way to state the independent variable for this example is to say presence of children while cartoon watching. That would also be acceptable. If you were to state the independent variable that way, the two levels would simply be yes or no. In other words, in one condition there were other children present, and in the other condition there were not. The dependent variable could still be funny rating. So I want you to remember that there isn't necessarily just one correct way to state the independent variable and the levels. What is important is that you focus on the variable and not the people in the study. This is crucial. People can never be variables. What they do, or the situation that they're placed in, or what happened to them, are variables. So for this example, it would not be correct to put children for any of the three answers. The children are not the variables. The condition that they were in and their funny rating are the two variables. Alright, let me read you another example, and I'd like for you to pause the lecture and see if you can identify the independent variable, the levels of the independent variable, and the dependent variable. A history test was given to a class, and the professor compared the scores between students who had previously taken a history class and those who had not. Let me read it again. A history test was given to a class, and the professor compared the scores between students who had previously taken a history class and those who had not. Here's the answer to the history test example. The independent variable in this case is taking a history class. The levels are yes and no. The dependent variable is test scores. So in this example, it is believed that there is a cause and effect relationship between previous history class taking and test scores. Independent variable, dependent variable. Again, you can word the independent variable and the levels of independent variable a little bit differently, as long as you don't use people. Not the class, not students, not professor. The independent variable is really whether or not the students had taken a history class, and we are studying its possible effect on history test performance. Let's try another one. Some elementary school teachers were told that a student's parents were college graduates. Other teachers were told that the student's parents had not finished high school. The teachers then rated the student's academic potential. Let me read it again. Some elementary school teachers were told that a student's parents were college graduates. Other teachers were told that the student's parents had not finished high school. The teachers then rated the student's academic potential. For the elementary school study, the independent variable is information told to the teachers. Another way to say it is parents' education status, because they really are synonymous. Both of those reflect what the independent variable was. The levels of the independent variable, if you put something along the lines of information told to the teachers, the levels would be college graduates and not finished high school, or not high school graduates. I think that would probably apply even if you put parents' education status as the independent variable. The dependent variable in this example, the outcome, the expected effect, is going to be on the rating of the student's academic potential. In other words, the hypothesis here is there is a relationship between what a teacher is told about the parent's education status and his or her belief about the student's academic potential. Cause and effect. Information told to the teacher affects the teacher's perception of the student's academic potential. Okay, one more example and then we'll move on. The number of sick days taken by factory workers was examined for 2 months after half of them completed a stress management program. Let me read it again. The number of sick days taken by factory workers was examined for 2 months after half of them completed a stress management program. The independent variable in the sick days study is completion of the stress management program. The levels is yes or no. The dependent variable is the number of sick days. So the hypothesis here is that taking or completing a stress management program will affect the number of sick days taken. Independent variable affects dependent variable. If you would like more examples of identifying independent and dependent variables in experiments, I have on our course page some websites that you can go to for more independent and dependent variable help. It would be great just to review some because you may be responsible for these on homework or exams. Being able to identify the independent variable, the levels of the independent variable, and the dependent variable within an experiment. So again, this type of data collection approach is used when we are trying to establish not only if a relationship exists between two variables, but if that relationship is cause and effect. If you go to the next slide, we're moving into step 4 in research methods, which is data analysis. Now, this is not a statistics class, so you will not need to know a lot of ins and outs about data analysis. But it is important for students to know what researchers do with the data once it is collected, once we collect the information from those variables. Data analysis can be broken down into 2 major categories: descriptive statistics and inferential statistics. Descriptive statistics are what we use to help us describe our sample. It may be generalized to a population, but really we are trying to describe what is going on in our sample. Let me give you a few examples of descriptive statistics. With respect to addiction, we might want to know within our sample what was the average age of our sample's first drink. What is the average cost of treatment? What is the average number of days sober after treatment? What percentage of people with addiction come from divorced homes? Those are all examples of descriptive statistics. All we're doing is simply summarizing information about our sample. It can be quantitative information, it can be qualitative or categorical information. What percentage of our sample of people with addiction are male and female? That would be another descriptive statistic. If we want to take the next step to test our hypotheses and try to make the conclusion that our relationship, our hypothesis in our sample generalizes to a larger population, we would then use what are called inferential statistics. We can use inferential statistics to test cause and effect relationships or to test non-causal relationships. So, for 2 examples, let's go back to the 2 original hypotheses that I stated in step 1. Hypothesis 1. People who complete a drug rehabilitation program are more likely to abstain from drug use. In order to test that hypothesis statistically, I would have to compare the abstinence rate between people who participated in the program and people who did not. That's where statistics would come in. I would be able to compare the number of people who abstained from the number of people who did not and make a determination as to whether or not there was a statistically significant difference between those two groups. If I want to test non-causal relationships, I might use what's called a correlation. A correlation assesses the amount of relationship or the strength of the relationship between two numerical variables. To give you an example, let me go back to the second hypothesis. There is a relationship between the amount of time spent in a drug rehabilitation program and the number of days sober after the program ends. In this situation, I'm trying to relate two numerical variables: the amount of time spent in the program and the number of days sober after the program ends. If we show that the more time you spend in a program, the more days sober you have, that is an example of a positive correlation. In a positive correlation, as one variable increases, so does the other variable. So again, if the number of days in the program increases, and so does the number of days sober, we would say there is a positive correlation between those two variables. Because this is an example of a non-causal hypothesis, though, I can't say with certainty that the number of days you spend in the program causes the number of days of sobriety to increase. That would require an experiment. So if I'm simply assessing if two variables are related, I cannot necessarily draw a cause and effect conclusion between them. Another possible form of correlation between two numerical variables is called a negative correlation. In a negative correlation, as one variable increases, the other variable decreases, or vice versa. As one variable decreases, the other variable increases. Let me give you an example of a negative correlation. There is a relationship between the age of first drink and number of neurons lost in the brain with alcohol use. Let me say that again as an example of a negative correlation. There is a relationship between age of first drink and the number of neurons lost from alcohol use. So I want you to think about that relationship. The lower the age of the first drink, the higher the number of neuron loss. As one variable goes down, the other variable goes up. So that's an example of a negative correlation. The relationship is definitely there, but the relationship moves in opposite directions. In psychology research, we see many examples of both positive and negative correlations. The key is that the variables are in fact related. They do move together, but whether they move in the same direction or the opposite direction depends on whether or not we have a positive or negative relationship. The last step in research is to draw our conclusions and report the results. Once we collect the data, and once we perform analyses on the data, we are able to go back to our hypotheses and determine whether or not they were supported. In research, we never use the word prove. Whether or not we support our hypothesis is based on imperfect data collection from an imperfect sample using statistics that rely on probabilities. So nowhere in a research situation is there absolute proof or absolute fact. We speak in terms of likelihoods. If we find evidence to support our hypothesis, we would conclude that our hypothesis is likely true. But we never, ever use what I call the P word. We never say prove. For instance, we can never prove that people who complete a drug rehabilitation program are more likely to abstain from drug use. We can use our data analysis results to say that it is likely, or that our data supports this hypothesis. So the first step at the end of the study is to evaluate our hypothesis in light of the results obtained. But that's not the end of good research. Good studies are replicable. That means the study was designed in such a way that other researchers can repeat it or replicate it. A good study will have replicable results. That is, another researcher will come to the same conclusion as the original researcher did because it was a good, sound study. The sample was good. The variables were operationally defined, and the hypothesis was clear. Another hallmark of a good study is that it is what we call externally valid. That means if our hypothesis is supported, it would be supported in other samples and in other settings. So if we believe, or if we find through our research, that people who complete a drug rehabilitation program are more likely to abstain from drug use, that should be found in other settings, in other programs, in other regions, with different age groups, different genders, different nationalities. It should be externally valid. A synonym for externally valid is generalizable. The results should generalize to other populations in other settings. That's the end of the lecture on research methods.